Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900 into tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, let's localize the routing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 at Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, or the steepness of the trigonometric angles and get line the descent. We can select the flight path angle from the autopilot flight director system panel. We have also the barometric pressure of the outside atmosphere, the altitude indicator with the pitch ladder in degrees and the bank angle in degrees. We have the Lszh localizer of the instrument landing system that receives the radio frequency transmitted from the airport threshold antennas, so we can receive the radio frequency from the onboard antennas of the aircraft and can align the aircraft with the magnetic North Pole heading of the Lszh localizer, the horizontal localizer and the vertical glide slope, so we can align and land using the instrument launch system, the Lszh localizer that has a unique radio frequency for its runway and airport and heading, so we can use 136 degrees for this runway, the runway 14 in Zurich International Airport. So you will see how we're going to use the Lszh localizer for the horizontal localizer alignment and the vertical glide slope for approach and landing, and also we can see it in takeoff. So we have also the Lszh localizer crossguards. We have the flight director crossguards for manual guidance of the aircraft and the autopilot crossguards for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and on zero with the autopilot and the autothrottle. Later on vertical navigation we have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, and also the decorated display of the flight plan we can use to fly the aircraft through some waypoints which are connected with the magenta operable line. You will see later I'm going to use the flight management computer over here to create a flight plan or a flight path or a route. We have also the navigation display that displays the magnetic North Pole and the geographic North Pole and the magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the terrain displayed with red, green and yellow or amber color indication depending on how far away it is located from our aircraft and the altitude difference. Also you can see the terrain map. We have the red, green, yellow color. We have also the blue for the lakes, the rivers and the sea. We have the airports displayed in the terrain map with a 4-letter ICAO name with a blue letter, and also we can see the runways we're going to use for takeoff and for landing, and the taxiways of each airport, the runway length and the direction, so we can align with the magnetic compass or geographic. So also we have the workstation ADFs and DBs, which are navigation aids. So we have the nav aids and also the waypoints, which are horizontal and vertical navigation fixes and altitude and speed constraints. The aircraft is gonna have to fly through some when we're gonna be flying. We're gonna select from the flight management computer, as I told you, it's gonna connect the line of the flight plan displayed in the navigation display. So you can see the horizontal and vertical profile of the aircraft as we're gonna be flying. So you can see here the horizontal and vertical profile. You can see the terrain over here with the red, amber and green indication, the airports where they are located, the distance, 18 nautical miles. So you can set the distance here, the range of the map. Also you can select the mode, what to display, whether radar, traffic, terrain, plan, map or menu over here. So this is the navigation display. So you can see in the vertical, the aircraft right now is on the ground, 1430 feet. When we're gonna be flying, we're gonna select an altitude from the autopilot flight director system panel. So also in the navigation display you can see the other aircraft using the transporter, the ADSB and ADC transmits receiver, the transmits our frequency to other aircraft, and the air traffic control and receives from the other aircraft. It can calculate using its computers the other aircraft location and distance from our aircraft bearing, and also altitude difference from our aircraft, how many feet, hundreds and tens and thousands of feet are above or below us. Also whether the climb or descent with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft. It gives us a warning from the TCAS system, the traffic collision advisory system. We have an incoming collision with another aircraft also in the ground. Also we have other things to see. I'm gonna show you right here. So you're gonna see here we have many systems. So I'm gonna show you also the autopilot flight director system manual, the engines indications, the ACAS, the thrust levers, the flight controls. I'm using the flight controls. Over here I have the side stick I'm using for controlling the flight controls of the aircraft. So we can use the pitch axis to climb a descent, the bank roll over here to make left and right turns, the control wheel. So we have the side stick, left and right deflection like in the Airbus aircraft. Also we have the pitch axis, which is moving back and forth in the side stick in the Airbus aircraft. This is the yoke forward and aft movement for climb or descent. And we have also the rudder pedals over here. We have the thrust levers over here. We can control using this slider over here. So this is the thrust levers. You can see the thrust indication commanded by the FADEX. The FADEX over here display all the engine data, so I'll explain you in a couple of minutes. Also the outside view of the aircraft, the aerodynamics. So you can see here we have the primary flight display, what it displays. You can see we have the airspeed indicated over here, the airspeed tape, so it will increase as we're gonna be flying. Right now it's 30 knots, nautical miles per hour. The airspeed selected from the autopilot flight director system panel, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere 39.92 inches of mercury over here, and also the radio minimum altitude. So you can see also the radio altitude can go up to 2,500 feet above the ground using the radio signal from the antenna on board the antenna of the aircraft. So we have also the barometric altitude, the target altitude selected from the autopilot flight director system panel with purple color also. The vertical rate of climb descent of the aircraft 10,000 feet per minute. This needle is a vertical speed indicator, so you can see 500, 1000, 1500, 2000, 3000, 6000 feet per minute climbed or descent. So it will move down with descending. You can see also the artificial horizon with the blue and the other color, the brown. So we have also the pitch ladder degrees over here, 2.5, 5, 7.5, 15, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up and pitch down. Also the bank roll in flight, how many degrees, like 10, 15, 20, 30, 45 degrees of bank roll. So you can see 5, 10 over here degrees. So also we have the flight director. You can see the pitch ladder. It will move up when we have a positive pitch attitude and down when we have a negative pitch attitude. The wings level over here. Also we have also the angle of attack of the aircraft as it flies, and the flight mode on 0 with the autopilot and the auto throttle. Later on vertical navigation mode. So right now we have the takeoff, go around armed Also you can see the HSI over here, horizontal situation indicator. So after I'm gonna set up the flight management computer, is gonna have a different outlook. The whole all displays over here. So you can see also the altitude 10,000 feet also is selected, displayed in the vertical profile over here. As we're gonna be flying, you're gonna see the needle, this line here. So we can change it as we fly. Select a different target altitude, different target values. So you see the same values are displayed here: 200 nautical miles, 360 heading, and 10,000 feet for the target altitude. We have also the vertical speed of the aircraft. This is the autopilot flight director system panel. So you see 200 over here for the airspeed guidance, 10,000 is also displayed over here in the primary flight display. As we can see, 200 and 10,000 feet. Also the heading 360 degrees is 0, is the same heading. It's going so we have also the autopilot engage and disengage switch over here. The LNAV and the VNAV function of the airspeed guide of the autopilot flight director system panel modes, the flight level change, auto throttle, climb continues, the heading, the airspeed actually, and the heading. So we can set auto throttle left and right, flight director engage and disengage on and off. Also you can see here the heading, bank angle. We can press also the switches, the vertical speed, flight path angle, and the altitude over here, and the VOR localizer and the approach for autotalon. Also you can see the other side, primary flight display displays all the same things as the other side. Also the airports here where they are located. So I'm gonna show you all the systems before making an engine start demonstration. You can see also the head-up display displays all the same things like the primary flight display down here. So you can see also that tells you we have the barometric pressure of the outside atmosphere. We set the barometric altitude by setting the barometric pressure 29.92 inches of mercury over here. Using the baro set over here, so you can set inches of mercury hectopascals, 29.92 right now, or 1013 hectopascals, and radio minimums. The other things are plan, range, weather radar, traffic over here. So you can see takeoff ground over here, 10,000 feet airspeed, and the barometric altitude, 29.92 inches of mercury. So we can set lower or higher pressure altitude also. I'm gonna show you the other systems, what the engines are also displayed over here. So we have the N1, or maybe I can leave it later, which is the low speed starters have low pressure compressor and turbine of the turbofan engine. The takeoff limit 99.2%, 99.2, the total temperature, also the limits with green, and the never exceed with red, and the yellow limits. Exhaust gas temperature per engine left and right. The N2, which is the high speed starters have the high pressure compressor turbine of the turbofan engine left and right over here. The fuel flow points per 1,000 kilograms, thousands of pounds, oil pressure, oil temperature over here, oil quantity, and the vibration of the N2 stage of the engine. So the FAREX control monitor all the system data you see over here for the engines. Also the cabin altitude as we climb higher. You can see we have the cabin pressurization. So as we climb, we pressurize, we descend with the pressure. You can use forward and aft, open and climb. The outflow valves that receives also the cabin pressurization from the bleeder from the engines. So we have when we fly at 45,000 feet, the cabin altitude should read about 6, 7 or 8,000 feet maximum, and also the differential pressure should be 7.8 or 8 psi. So this is for the landing indication. Also is going to be selected automatically, the landing altitude. for the pressurizing the cabin. So you can see the pressurizing here, the also valves forward and aft open, also and close in the manual mode. So we have them in the automatic mode right now. Also you can see we have here in the flight controls the horizontal trim stabilizer over here. So you can see the horizontal tail trim of the elevator. This way pits up and this way pits down. As you can see, we can trim and we can see the horizontal trim stabilizer position over here, how many degrees, nose down or nose up, stabilizer trim. Also the flaps and the rudder trim, other indications, landing gear down right now. So we have the normal and the alternate channel of the pitch trim of nose up or nose down. So this way we trim the elevator of the aircraft up, and this way you trim the elevator down. So you give an effect in flight, aerodynamic effect, to pitch the nose up this way and pitch the nose down as you fly this way. So you can see nose up and nose down as it reads. Also we have the parking brakes over here, as you can see. We have the stabilizer cutoff switch over here. So this is to open up and from normal to cut off the stabilizer trimming. So this is a later explanation here for the stabilizer trim cutoff switch. Also you can see the flight control computers that we have. So this is a fly-by-wire aircraft. So we have them in the auto position, flight control computers primary. So we have also the automatic trim function from this aircraft. So this is a fly-by-wire aircraft. It has the automatic trim also from the flight control computers when we are airborne. When we use the autopilot flight directors, is set one of the auto throttles. All the flight management computer inputs like the manual function trims itself automatically. So you can use also the manual trimming. So I'm gonna show you the flight controls of the Boeing 787. I'm gonna start with the horizontal elevator, the horizontal tail elevator trim switch. So we have the normal switch over here. We have the alternate and also the cutoff switch for the auto trim function of the aircraft. So you can see here also the outside view. You can see here we can trim out this section as we fly. We have the elevator for climb and descent like this, and we can also use the trim switch I have here to pitch up the nose up and pitch down also. So I'm gonna show you all the flight controls function one by one. So we start here with our so you can see we have the horizontal trim stabilizer over here, elevator trim. Left click down, right click up, as you can see over here, this tag. You can see also the flap speed here. So we have the elevator trim, left click down and right click up. So this way you trim the elevator up, you pitch the nose up. This way you pitch, you trim the elevator down and you pitch the nose down as you fly. So you need to remember. Also we have the head-up display declutter switch in the control wheel of the aircraft. So this control wheel, the autopilot disengage over here switch. So we use mainly that with manual flying. So I'm gonna show you here. We have also the alternate, as I told you, pitch trim switch. This way you pitch the nose up, you trim the elevator up. This way you pitch the nose down. So we have the automatic trim. So if you have a failure over here that affects the hydraulic system, as you can see, this is hydraulic, the primary demand engine driven and electric driven pumps. So if we have a failure, it will affect the primary flight control computers, the auto trim function. So so we're gonna have a failure of the auto trim. In this case we have to come down here, and you can see we have to open this guarded switch from normal to cut off. So this is for all Boeing 737, 47757, Boeing 767, Boeing 777, and Boeing 787 aircraft. You open from normal to cut off this switch, and you have only you lose the automatic trim function of the aircraft, and you have only the alternate and the normal pitch trim over here. So you don't have the trim wheel like in the other aircraft. So you use this trim switch instead of having the automatic. You have the manual, the normal flight control channel and the alternate channel, like this all the time. So I'm gonna show you now the flight controls of the aircraft. I will talk to you about the Newton's physics, aeronautical and aerospace engineering, show you the outside view and derive some principles we need to know for flying the aircraft, for the air transport pilot license, and for the commercial pilot license we need to know some aerodynamics, the Newton's physics and the Bernoulli feeder fluids. So I will show you the outside view and show you and explain you some principles. So you can see here we have the outside view of the aircraft. You can see the surface area of the wings, of the forward wings, hold the weight of the aircraft as the aircraft flies. Also you can see we have the thrust vectors from the engines, the jet blast. So you can see we have the turbofan turbojet engines, we have the exhaust cone here, the jet blast from the engines, below the high pressure compressor and turbines of the engines, and the front fans and the bypass over here of the engines, the left and the right. We have also here in the wings, you can see the mean aerodynamic chord position, which is 23% of the Mach approximately, is where the maximum aerodynamic lift occurs in the forward wings. It's also where the center of pressure is moving forward and aft over the top surface of the wings. It's also the position where the stall, the airflow becomes detached from the top surface of the wings all the way back, and the aircraft wings stall for a given angle of attack in flight, and also an airspeed that is either increasing or decreasing. So we need to monitor here when we fly in the primary flight display all the time. We need to monitor the airspeed is above the stall speed that is displayed with a number and red indication, usually below that. A warning indication. We have the stall speed just below the airspeed, so we need to apply more thrust over here and push the stick down, the yoke down of the aircraft, or the side stick, to increase the airspeed of the aircraft as we fly, to avoid the stall. So you can see also here we have also is where the fuel tank, the center fuel tank, and the left and the right wing fuel tank are located. So we have the center of gravity transverses through here, this position where the mean aerodynamic chord of the forward wings is. It's also the center of gravity. It's also the yawing axis of the aircraft, where the nose wheel, the forward nose wheel, and the rudder are used, the vertical stabilizer, to maneuver the aircraft either in the ground or in the air as we take off, or in the air as we fly. So the yawing axis is also the rudder pedals use axis. The side stick I have here is the left and the right rudder pedal movement, as you can see. So these are the rudder pedals that use the rudder. As you can see, rudder pedals, left rudder, right rudder. Also we have the tiller, the nose wheel steering. So the nose wheel is interconnected with the rudder in the ground, so you can use the wheels, the forward wheels, as you can see here, the forward wheels of the aircraft that deflect either 76 degrees left and right from 0 knots airspeed all the way up to 45 knots. In 45 knots we have the rudder aerodynamically effective at takeoff or at landing. So the nose wheel decreases in deflection from 7d6 to like 7.6 maximum, and then all the way up to like 70 or 80 knots in takeoff, like 200 kilometers an hour it like 140 kilometers an hour. It disconnects, so we have only the rudder aerodynamically effective for controlling the aircraft above 80 knots in takeoff or in landing. So you lose the nose wheel. It locks above 70 or 80 knots in most aircraft. In the Airbus easily is doing these things. So this is the nose wheel and the rudder, the vertical, the yawing axis, the transverses all the way down to the center of gravity of the aircraft. So you see the rudders here, rudder pedals. So we have also this axis here from wingtip to wingtip over here. It's the pitch axis. We can use the tail of the aircraft, the horizontal stabilizer over here for climb and descent the aircraft like this. So it's the side stick of the Airbus climb, pull up or pull down, or the yoke as you can see in the Boeing aircraft. So this is the pitch axis. You climb and you descend. The side stick up and down in the Airbus, back and forth. Is the control column of the yoke of the Boeing 787, as you can see. So you climb and you descend like this, as you can see. So there is no difference between the Airbus and the Boeing flight controls. They control the same things when you fly. You just have the side stick in the Airbus and the yoke in the Boeing. That's the only difference. So you can see the elevator that we also can trim over here, moving down, descent, or up, climb with the Airbus. So this is the pitch axis. We have also one more axis from nose to tail. Is the longitudinal axis. The transverses, all other axes is the left and right ailerons and spoilers in the Airbus, and flaperons, ailerons and spoilers in the Boeing. Is the longitudinal axis, the roll axis. So you can see the side stick, left turn and right turn like this in the Airbus. So you can see the ailerons over here and spoilers deflected. Same like in the Airbus and the Boeing, no difference of the flight controls output. So it's also the control wheel over here in the Boeing aircraft to make left and right turns. Is the side stick, left and right turns in the Airbus aircraft. So the Boeing has the control wheel. So the control wheel for the flight controls of the Boeing, and the yoke, and the side stick in the Airbus, and the rudder pedals, nose wheel steering and rudder. So this is the main explanation of the flight controls. Also you can see here one more from the aerodynamics. You can see the wings of the aircraft. The bottom surface of the wings is more flat, and also we have the flaps extended, and when we fly we have mainly a positive angle of attack of the wings. So using the Bernoulli theory of fluids, the airflow is moving slower below the wings, so we have higher air pressure, which pressurizes the aircraft weight and wings up into the air as we fly. Also you can see the top surface of the wings. They have higher curvature over here as we fly. They are more curved, so we have higher airflow, higher speed of the airflow above the wings. So using the Bernoulli theory of fluids, we have lower air pressure, which sucks the aircraft wings and weight up into the air. So this is the basic aerodynamic principles. I will show you now the inside again of the aircraft. One more view, perhaps of the flight controls. So we have one more view of the flight controls of the Boeing 787, and I'm gonna start showing you the other systems of the aircraft and make the engine start demonstration. So stay until the end part of the video. You're gonna see the complete flight from takeoff, climb, cruise, descent, approach, and landing. Full manual. I'm gonna fly manually this aircraft. So I'm gonna start now showing you over here this view. We have the side stick, as you can see, and the computer, the mouse pad over here that I'm using to fly the aircraft. So this is the whole setup. You can see it's like in the aircraft and also over here we have so I'm gonna show you one more view of the aircraft. So you can see again, climb and descent like this. So you can see the side stick deflection is proportional to the yoke deflection. All flight controls move together. So you climb and you descend, you make turns to the right, turns to the left over here. So left turns, right turns, the Airbus side stick, the thrust levers also over here, the horizontal trim stabilizer. Also you can see the captain and the first officer are interconnected and move together in flight, both sides, both yokes in the Boeing aircraft. Unless you have a failure, you can override either one. In the Airbus you have the side stick priority button, so flight controls in the Boeing are interconnected for movement. Also you can see we have the thrust levers over here. You can use the thrust levers like this. So we have the flight controls like this and the thrust levers. You can see the thrust levers movement over here. How much percent you can set the engine's thrust. Command it like this. So you can see the thrust levers moving forward or aft. So this is the main flight controls, the thrust levers function. Also I'm gonna show you a little bit the outside view. You can see also with this view of the flight controls also, and I'm showing you here. So you can climb, descend over here using the tail, the rudder pedals, the rudder and the nose wheel steering, and also the ailerons and the flaperons, ailerons and spoilers over here. So this is most of the flight controls we need to know for flying the Boeing 787 aircraft. Also the outside view of the flight controls, the thrust levers over here. So I'm gonna start in a couple of minutes, so I need the other systems, the flight management computer we need to set up for flying the aircraft. So you can see we have an approaching aircraft right now. So this is all for the flight controls right now. Elevator, aileron spoilers over here, side stick left, all flight controls together, just like in the original aircraft, either Boeing or Airbus. So this is the flight controls lesson for tonight. As you can see, hope you have better view. Left and right turns, climb and descend. So I'm gonna start showing now the flight management computer over here. So I'm gonna use the flight management computer to input all the data of the aircraft for this flight. I'm gonna use the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank, how much percent we have. Right now we have 30% in the left wing and 30% in the right wing and 10% in the center tank. The flight management computer is gonna calculate the center of gravity from takeoff, before takeoff actually. For the mean aerodynamic core position, where the maximum aerodynamic lift occurs and where the stall begins in the wings. We're going to be having the center of gravity and the horizontal trim stabilizer for takeoff for 25 degrees over here. So we're going to be having also the flight management computer. So we're going to be having the flaps for takeoff. I'm gonna set 15 degrees of flaps, and the flight management computer is gonna calculate. We're gonna use the runway for takeoff, the Zurich International Airport Lszh in Switzerland, runway 14. The flight management computer is gonna calculate the runway length, the runway slope, the wind direction, speed, the barometric pressure, the temperature of the air, and also other data like the runway conditions. We decide where it is gonna give us the takeoff speeds, V1, we rotate V2 like 130, 140 knots. We're gonna use full takeoff power, 99 to 100% from the engines for takeoff. So we're gonna be having also 9 degrees of pitch attitude for rotation. We take off rotation and climb. We're gonna climb and we're gonna have the seats, the southern edge, the departure waypoints and fixes that include horizontal, vertical navigation fixes and altitude and airspeed constraints for the initial departure and climb of the aircraft. We're gonna be climbing to the cruise level of 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna be cross through some waypoints and make some turns, and then we're gonna initiate the descent back to the elevation of the airport, like 7 or 6,000 feet above the sea level. I'm going to be aligned with the magnetic north pole heading of the runway, 136 degrees for the stars. The southern terminal are and all waypoints and fixes that include horizontal and vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing, the north final and the south final, and also the ILS localizer. The instrument landing system that uses the threshold antennas that translate the radio frequency that is received from the onboard antennas of the aircraft by tuning separate frequency for its runway and magnetic north pole heading. So I'm going to be using 136 degrees of magnetic north pole heading for this runway localizer, and also we're going to be having the vertical glide slope for approach and landing. We're going to be having an airspeed of about 160, 170 nautical miles per hour or knots for approach and landing. Using the ILS localizer, also the flaps 25 to 30 degrees, the thrust set in the engine 60 or 70%, and also pitch attitude of 9 degrees or less, and the landing gear extended. So you're going to be having a complete flight manual, and also the flight plan or flight path or route. I'm going to show you now how to use over here the flight management computer to create the route of the aircraft. So you can see here I'm having again the computer of mine over here, and also I'm having this mouse pad. We can use also the mouse pad inside the aircraft, as you can see. So I'm using this mouse pad and the keyboard over here. I'm having the control of the aircraft. So we have the flight management computer over here. You can see we have this touch screen mouse pad, left and right input. You can set here what you need in the screen. So we set the index here. We have the identity of the aircraft, Boeing 787 900 model, CNX engines, also position, performance, takeoff, approach, annunciate status, navigation, data alert, traffic control, and also other modes we can press here. The keyboard we can select, and also we can use the mouse pad for using other screens over here. Make selections. So we go in this view of the cockpit now to set up the flight management computer. So you can see we have the mouse pad again, this view of the cockpit. So I'm gonna set up the flight management computer. We have again identity, Boeing 787, CNX engines, and the Iraq cycle, position, Lszh Zurich International Airport, Lszh in Switzerland. We can set the inertial reference position for alignment. So also we can set over here the index, performance, takeoff, approach, annunciate status, navigation, data alert to traffic control. So we have performance, 0 fuel weight, 382.7 thousand pounds gross fuel on board, 34,000 pounds gross weight, 356.7. The reserve fuel, cruising altitude and cost index, fuel freezing temperature. So gonna be set first the departure. Over here, Lszh Zurich International Airport, Lszh departure arrival, origin and destination. So clear the discontinuity. Runway 14 over here. Departure and arrival. So we set departures runway 10, 14, 16, 28, 32. So we can select runway 14, transit to Alpha over here. The scissors, other instrument departure waypoints and fixes, and altitude and airspeed constraints. And also we set the arrival over here, arrivals. So we have Lszh 16, 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we can set ILS 14, trans Amiki over here, and trans Negria. So we can set over here departure and arrivals, the legs over here. So we have the route is not active yet, is displayed with blue. The heading, first waypoint, Zui over here, distance one waypoint by another, climb to the Negria Mative, descend then, approach and landing, Zui 0701, the runway here. So we have initialize the reserve fuel plus fuel on board, 0 fuel weight plus fuel on board, takeoff gross weight, cruising altitude 25,300 feet over here, cost index 100%, fuel freezing temperature over here. So we circulate the fuel and cruising center of gravity. So we press the execute, disactivates the route. So we have the heading, first waypoint after takeoff, 136 heading, 2 nautical miles, 250 knots, 1900 alpha, 1 nautical miles. We make left turn over here, 3 nautical miles, 5 nautical miles, heading 0528, 6 nautical miles, 301 knots, 6000 alpha. Next page we have Negria 071, 36 nautical miles from Zui, 301 knots, flight level 22,200. Then we make a right turn to go back to the airport, 12 nautical miles from Negria. Is the Mative 11,800. Amiki 2580 heading, 258 heading, 6 nautical miles from Matic, 190, 10,400. Zurich 275 degrees, 9 nautical miles, 180, 7,000 alpha. Zurich 701, 186,000 alpha. You can see the distance, TR8, 3 nautical miles, 185,000 alpha. CI 1480 to 4,000 alpha. Osnem 5 nautical miles, 174,000 alpha. We make a left turn here in CI 14 for runway 14, 8 nautical miles from Osnem, 140 knots and 1,400 30 feet. We also use flaps for takeoff, 15 degrees, center of gravity over here 4.25 degrees, and takeoff speeds V1, V0, V2 for the runway position. So we have also departure arrival, alternate, VNAV, progress over here. We can set a hold over a waypoint in flight, the fix, and the navigation radio, tune ILS or ADF. So we use the legs here. You can see over here we almost finished with the settings, pre-flight settings. So you can see the flight run displayed here, but we have the runways also, how close we can see the taxiway, the terrain in front of us with the yellow and green and red. So we're going to be flying, you're going to see the terrain, the distance, also the flight run. I'm going to show you maybe later a better view. Also the plan map setting over here, the elevation of the terrains over here. So we're gonna set over here the distance again, so you can see the flight run we created. So we're going over here in the overhead panel. We're gonna set we need to start the engines right now in a couple of minutes. So we have the APU, we need to start it. It's gonna provide us hydraulic, and it's gonna provide us with electric power and pressurizer. We have the contactors, 130 to 200 volts for 100 Hz frequency, left and right, engine driving, the battery, primary flight control computers in the auto position over here, heading reference, IRS, inertial reference system alignment, flight control surfaces over here, battery, towing power, FT door, and passenger oxygen over here, window heat, rammer turbine, and hydraulics over here. Off position, the primary and the demand. You will see what they display here now. Because we turn them off, we can turn back to the on and the auto position. Primary demand. We have electric also. We have the recorders. We have the cargo and APU fire, the electronic engine control for the engines with the auto start. You can see the auto start system and the normal and the alternate mode of the engines. Controls the farex. We have also the fuel jettison. We can dump some fuel over here in flight, and if we arm this and select the nozzles and how much to remain, so we can make an emergency landing with less fuel. We have the fuel left and right wing, fuel tank, the fuel booster pumps, the crossfit valve. We can feed either engine with either pump or either tank. We have a failure and balance the fuel between the left and right wing tank, the center tanks also. The balance. So we have also wing and engine on the ice over here, or in auto. We have also the cabin pressurization system over here in the auto, in the manual position. We use the outflow valves over here for climb and descent, open and close. In the auto we need nothing to do. Also we have the pressurizer from the engines and from the APU. We need for cabin pressurization, oxygen regulation in flight, wing and engine on the ice, hydraulic fluid tanks also, pressurization, and some other systems. So we're gonna see now the last thing before going into takeoff, the systems display here. So we have the systems over here. You can see very quick the hydraulics, APU, oxygen, liquid cooling over here. So we have also the electric. You can see the electric APU is running left and right, IZ 130 to 200 volts for 100 Hz frequency. The battery, main battery, and APU battery over here, voltage, the drives. So we have the hydraulic, where the hydraulic fluid goes, which is used, set-off valves, primary and demand, engine driving and electric driving. 5100 psi in its container, and the quantity of hydraulic fluid, the fuel on board the aircraft, left and right wing, fuel tank and center tank. We have 11,000, 11,000 and 11,000, total 33,500. Also you can see low and high pressure fuel valves, left and right engine are feed from the center or left and right wing. The crossfit valve is off, but we turn it on. You will feed either engine with either pump or either tank and balance the fuel between the left and right wing. The APU is fed from the left wing using the DC motor. Also, you can see here the minimum fuel temperature, below which the fuel will freeze, minus 37 degrees, and the fuel temperature right now. So we circulate the fuel in flight from the FADEX automatically to the engines to heat up the fuel, also the oil and the lubricant, the air. We have pressurizer from the engines through the packs. The doors are closed, the cabin can be pressurized, the gear, the temperature of the brakes, and the pressure of the tires over here. Flight controls, the movement. Last thing to see here, the movement of the flight controls. So we can have the deflection of the left and right wing, climb, descend, the elevator, and the rudder pedals, and also the horizontal trim stabilizer. So this is the last thing before going into flight to check. Over here the flight controls are moving accordingly, as you can see. So we have full flight controls movement. Also we can see here we have the FS display over here, the maintenance circuit breakers over here. So go back to the systems, and we have the checklist. Last thing to do, normal menu, before start, after start, before takeoff, after takeoff, climb, cruise test, and approach and landing. Back to the navigation display. We need to turn off both engines and restart them over here. So we're gonna make an engine start demonstration. So we turn off both fuel control, left and right engine. So we're gonna have the fuel starvation here, messages to the engines control. So we will look outside. You can see we have no fuel right now. The engines are starting down. So the engines are starting down. So we need to restart them. We go over here in the overhead panel very quickly. So we restart both left and right engine driving the auto start system. So you see the reconfiguration with amber color, all indications in the top. So we have the engines auto start. Now we have pressurizer admitted from the APU to the engines components. So you see we have only pressurizer, and we need to admit the fuel above 20%, both fuel to the run. So we have the auto start is to the on position. So it's increasing above 30%, 36, keeps increasing. So above 54%, the messages going off, and we have almost running engines above 61%. You can see the green message. So we can go for takeoff, set flaps for takeoff, speed brakes up. One last thing to set the autopilot, flight director, system panel. So you see auto throttle left and right over here, on and off. The airspeed, we can set the airspeed like this as we fly. So we're gonna set 253. We have the LNAV and the VNAV. Also the flight director over here, on and off. You can turn off. So we set back. Autopilot disengage over here. Bank angle over here, heading. So we set the heading of the runway we're gonna use for takeoff, 136 degrees. And also the vertical speed, the altitude here. I'm gonna set the altitude. And now the vertical speed, so we can descend over here, or we can climb. So we are ready for takeoff. Parking brakes off. We take the traffic control, the tower control clearance for takeoff. So we advance on the thrust levers to takeoff position when we reach the runway. And to taxi first, so we use less power, and also we use the tiller for steering. So the air traffic control give us the clearance. The runway is open for us. So we align here with the runway heading. So we advance the thrust levers to the full takeoff power, as you can see. Then we align with the runway heading over here for takeoff. So until 80 knots we hold the yoke down and also use the rudder pedals for alignment, as you can see. So we have 100 knots, V1, we rotate and we pitch up slightly, like 9 degrees for rotation, takeoff, rotation, and we go. So this is the takeoff. So we have positive rate of climb, landing gear up, so we can use over here. We can see all the air data of the aircraft, the terrain in front of you, around you. So you can see we are 1,000, 2,000 feet above the ground level, 2,300, 400, but 3,900 above the sea. The airspeed 172 knots, the pitch altitude like 20 degrees, and we climb with 5,000 feet per minute. Also the stall speed here with the yellow and red indication. Also you can see the wind direction and speed. We keep climbing over here. So we have the green below us over here. The reflections from the terrain radar below. So we are like 3,000 feet above the ground right now as we're climbing. So we need to make the turn now over here. So we have the sea, the lakes over here. So make a left turn. You can see the air dot again, the terrain below you, the airspeed, and the altitude. So we keep climbing over here. As we make the turn. So this is the air data for now as we climb. Also the head-up display over here. So you can look outside it, you see a beautiful view outside the aircraft in the Switzerland. I hope you like this beautiful view of the aircraft as we fly. The Swiss Alps over here, the Switzerland, the lakes. So we have also my homeland, the Germany, in front of you, the Bayern Munich. So you can see how we turn over here, quite easy. Need to align with the next waypoint. We're going to be overflying over here. So you can see also the view of the aircraft cockpit just after takeoff. So we need to align with the flight plan over here, make some left turn, then a right turn over here. You can see the wind direction, the waypoint we have to follow over here, the Zui, the ground speed of the aircraft over here, the range of the map, the engines also indication, the flight management computer, other settings like over here on the flight plan. So we need to make the turn now. So you can see here the waypoints we have to follow over here. So we need to be aligned here. So we overflying the legs here, as you can see. We have the Germany, my homeland, Bayern Munich in front of you, the lakes of the Switzerland, the Swiss Alps, the Italy, the France over here, and the beautiful galactic view. So we have a few more minutes to go for back to the airport. So we need to start the turn now. So use a little bit more flaps as we turn here. So you can see we can leave the hands off from the flight controls as we turn, no problem, or as we fly. So here we are, make the turn, overflying the Bayern Munich here, and the France, as you can see. So we overflying Germany, very close. And we have the Boeing 787, beautiful view over here, beautiful airliner. From almost 20,000 feet over here. To align with the flight plan, one more time, use a little bit right rudder as we turn. Keep climbing a little bit more. We need to align with the flight plan over here for this flight. Also increase the airspeed. We're gonna retract the flaps over here and picks up the aircraft a little bit down. So we need to climb a little bit more. So we have here the chemtrails, the frozen vapors from the exhaust of the aircraft. As you can see, beautiful view. So this is very beautiful view. We have the Germany behind us, the lakes and the beautiful star sign over here as we are overflying with the Boeing 787, as you can see. The lakes and the France in this way, the Germany. So this is the beautiful view over here. We need to start the descent in a couple of minutes. So we start descending the aircraft. Need to push down the stick a little bit more. So we are flying the airport now, as you can see. Speed brakes down over here. So we descend right now, as you can see, and we have the frozen vapors from behind. The chemtrails keep having them. So another nice view of the aircraft and the cockpit as we are flying. This place over here, you can see the runways we're gonna use for landing right now in the airport where it's located. Also displayed here in the navigation display, the primary flight display also. We are descending. Also the other side, primary flight display. The autopilot also panel. So we need to start the turn now in a couple of minutes. We are descending. So we start the turn now over here. Keep descending also. So this is the turn over here. We take the turn. And we need to be aligned with the airport also, the runway. We have 3 more minutes for approach and landing over here. So we keep using left rudder and keep descending the aircraft. Descent rate. So here we align with the runway, as you can see. Landing gear down over here. And also flaps we're gonna use for slowing down the aircraft, as you can see. We have a couple more minutes for approach and landing. So you can see. Couple more minutes for approach and landing over here, as you can see. Add some thrust right now, a bit of airspeed, we need airspeed. And also some flaps. We need 1 more minute for approach and landing. So you can see the idler's localizer also. The glide slope, we are inside the glide slope. And also the horizontal localizer, so we have some side wind, a little bit, not too much right now. So a little bit side wind. We need to align with the runway heading, as you can see. Side wind and wind gusts make it a little bit more difficult. Approaching landing, we need to use cross controls, control wind and rudder pedals together, as you can see. So we are almost here for the flare, for the runway touchdown, as you can see. So touchdown. We have parking brakes here and thrust reverse, full thrust reverse, as you can see. So we're slowing down, made a very beautiful slow down and landing. So we are aligned with the runway, the heading. Also the landing gear, you can see, is perfectly safe, there is no breakages. Also the thrust reversers over here. So we cancel the thrust reverse like this.